Hello everyone, my name is Gaurav Shakya. I have taken this topic named as electromagnetic induction, in short EMI. Okay, in this subject or in this tutorial, I will be asking about two questions. First is what this subject is all about. Okay, and the second is why we need to learn this subject. Okay, so what question comprises of what content or what topics we need to learn this in this subject. Okay, like flux, Faraday law, or emotional EMF, and like self induction and or mutual induction. That's and why question comprises of like why this topic is needed today, or why we need to learn this topic. That means why it is important for us, or why JE included this topic into their syllabus. Okay, so first come up with the question what is topic, what means electromagnetic induction, what is it? Okay, electromagnetic induction, specifically electromagnetic, that's this word comprises of two words, electro and magnetic. Okay, electro mainly refers to electric field, or electric field refers to charge, basically charge. Okay, and magnetic field refers to basically magnetic field. Okay, magnetic field. So electromagnetic means the interaction of the electric field and the magnetic field at the same time. What it means, let's say there is a conductor. Conductor could be any shape. Let's say this is a plate, conductor plate. If we talk about the conductor plate is in the space. Okay, in the space, and in this plate the electric field and the magnetic field both are present at the same time, and that means the electric field and the magnetic field, they interact each other and they produces some of the effects that are seen by the scientists, and they come up with the idea about like that phenomena called as the induction. Okay, induction means basically electric field, and the scientist who gave this phenomena, they known as a Michael Faraday, and they gave us two laws, first law of induction and second law of induction. We will gonna learn these two laws in the next couple of minutes. Okay, so mainly about electromagnetic induction, that is comprises of two words, electric and the magnetic, and the electric field basically it is combination of two fields, electric field and the magnetic field, and we considering two at the both at the same time. So that's why what means this is. Okay, let's come to the next question, why we included and why we need to learn this topic. Okay, if you talk about the why question, that means this is a very basic topic. If you talk about the electricity, in today's world electricity is the most important thing. We cannot live without it, and if you want to understand how electricity are generated and comes to our houses, this topic is the basic for that. The basic principle which are included in this topic are fundamental, or the building blocks of the whole infrastructure of the electricity. Okay, so if you talk about the why application of this topic, like electricity generation or generator, motor, fan, a mobile phone, PC, laptop, or many more. There could be like thousands of the application or thousands of the machine which works on the electricity. So that means if you want to understand like how electricity is generated and how these loads are consuming electricity, so we have to learn about the electromagnetic induction. Okay, so we let's say come to the next topic. Like the next topic, we gonna start the topic, the chapter electromagnetic induction. In this chapter, first thing we gonna learn is defining a flux. Let's define the flux. Okay, the first thing is the flux. Okay, what is flux? Flux is an entity or a physical quantity that is defined in mathematics. We generally use mathematics in vector calculus or applied mathematics, but this flux quantity has very dominant applications in the physics. Like flux, if you talk about the flux, like magnetic flux and electric flux, heat flux, energy flux, and this and that. So there are many use, like if you talk about the in heat transfer or many engineering discipline, they uses flux term. So let's define the flux mathematically, or we will come to the next topic. So if you talk about a surface, let's say this is the surface, okay, and this is the surface, like this is the surface, and these are the vectors, or you can say a field passing through this surface. Okay, they passing through this surface and this field called as f vector. If you want to write a flux for passing through this surface, what is the flux passing through this surface? And when you say flux, that means some kind of energy, some kind of charge, some kind of material that is passing through this surface, or means some material is projecting on this surface. So if you talk about the flux, that is defined as a dot product. Flux, if you talk about the flux, that means flux is equal to f dot n cap ds, this surface integral. Okay, this is the surface integral. Flux is a surface integral of any curve, any surface on which any vector is passing through it. Okay, that is the flux. And next is like the flux. We will discuss about the flux in the next couple of minutes. Again, let's first understand the Faraday's law of induction. Michael Faradays gave two laws of induction. First law of induction says that let me explain you in a layman manner, then I will deliver you the definition about the first law of induction. Let's say there is a ring, okay, a diameter r, that is placing on the surface, and let's say magnetic field That's magnetic field distribution. That means magnetic field in space is going inside, and the magnetic field is B, proportional to time. That's time varying. B is function of t. That means inside this ring, that is a metallic ring, that's metallic ring, and the metallic ring, inside the metallic ring, the magnetic field is time varying. And time varying, that means whether the magnetic field is increasing inside this ring or decreasing. So Michael Faraday says that if we place any conductor in the time varying magnetic field, and the flux passing through that conductor or that loop, basically a loop, that this is making a loop, flux passing through this loop is time varying or is a changing. That means that changing flux creates a EMF in this ring, this conductor. Changing flux creates a EMF. EMF means basically the magnetic field is changing, that's creating an electric field inside this conductor, and that electric field inducing the EMF. Okay, and the EMF, because of the EMF is inside this ring, that induces a current, and that current called as an induced current. Okay, that induced current. So first law of Faraday's law of induction is this, that when the magnetic field flux varies inside a ring, then the flux is varying. That means that varying flux creates induced EMF, and that induced EMF creates the induced current. Okay, and the second law of induction. The second law of induction says that whatever the magnitude of induced EMF is equal to the rate of change of flux in that region. Okay, so let's say this was the region where the magnetic field is changing. Okay, so let's say there is a center and there is a r is the radius. So if you talk about the magnitude of induced EMF in this ring, okay, E is equal to minus d phi by dt. Okay, and the phi is b dot ds integration. Okay, this is surface integral. Okay, surface integral basically are true integral. So why this is a minus sign? This minus sign shows that the induced EMF exhibits a property of opposing its cause. So induced EMF opposing its cause means it basically opposes the cause which it induced from it. Okay, that means this is a coil, because the magnetic field is changing, and that produces a changing flux, and flux is changing. That means the induced EMF is inducing, and the induced EMF magnitude is negative. That means it is opposing the magnetic field, and it is producing a magnetic field against the magnetic field which is exist in the space already. Okay, So that means the first law of induction, first law of induction is all about how EMF, defining the EMF, why, how EMF is generated. And the first law of induction and second law of induction is about the magnitude of, how we calculate the magnitude of the EMF. Okay, so that is called minus d phi by dt. Okay, so these are the two laws, and these are the basic laws of how electricity is generated, and these are the basic law you can use for any geometry. Okay, this is mathematics, just a mathematics. And now come to the next topic, is called motional EMF. That is the example to utilize these two laws of induction. So motional EMF means, of course the topic says the motional EMF, that means it comes from, because of the motion of any loop or any rod or any conductor. Okay, so let's consider a problem. There is a rod, okay, and there is a magnetic field in the space. Okay, this is rod and this is moving towards right side with velocity v. Okay, and the length of this rod is L, let's say L. Okay, so this is rod and this is a conductor rod. Okay, keep in mind that this is the conductor rod, and if it is not conductor rod, it is insulated, then there might be some changes in this problem. Okay, so this is a conductor rod moving towards let's say there is a point P and there is a point Q, towards Q. Okay, and the magnetic field inside this is named as B, and this is a constant magnetic field, it's not changing with time. Okay, this is the vector V inside this, inside the board. Okay, so the question is, what is the EMF, and there is R, EMF between P and R? That is the question. We have to solve about the EMF difference, induced EMF between this and this topic, this and this point. Okay, so let's calculate about this, how we calculate this. So first we have to zoom it about, understand what's happening in this rod. So let's say there is again this, and let's say there is a rod. Okay, in this rod, there is a inside rod, there is thousands and billions of the electrons floating around, and because of this is a conductor, that means inside this conductor the electrons are like a gas, the ideal gas. They are just random in motion. There is an electron that is moving forward with velocity b. Because the rod is also moving with velocity b, that means the electron also moving with the velocity b. Okay, and if you talk about this is the charge, this electron has a negative charge, and this charge is moving in the magnetic field. It has to experience a force, and that force, and so calculate the force on this electron. What would be the force? And the force, Lorentz force, F is equal to Q into V, let's say V cross B. That is the formula for calculating any charge moving in magnetic field, how much charge is experienced, that's come from this formula. Okay, this, so apply this. So V cross B, V cross B, that means the direction of the force will be upward. This is the direction, and the magnitude of FB is equal to E into V and V. Okay, V and V, but there is a difference, like this is a negative charge, that means the direction of the force will be negative. This is inside, so there is a force F is equal to EVV. But if you see this rod in the steady state, that means all the electrons experiencing the force from top to bottom, that means, and electrons are free to move, that means each electron from every electrons moving towards the bottom, okay. So moving towards the bottom means there is a positive charge and there is a negative charge getting accumulated. Okay, so if you talk about the final version of this rod, so there is a positive charge, there is a negative charge, and there is a steady state, means there is no redistribution of charge. So in steady state still velocity is V, but if you consider an electron, it is in equilibrium, means it balances both forces due to magnetic field because of the motion, and the forces because of there is electric field that is inside in this direction, because there is negative charge and there is a positive charge, and these both charge produces an electric field inside this conductor, and this electric field exerted force in this charge in upward direction, because this is a negative charge and there is a force which is already there, F barabar VVV. Okay, so in the steady state, let me rough this. In the steady state, what will happen, that is, in steady state both forces will balance itself. So if you talk about there is a E is equal to Q, that is the electron charge, E V, and E is equal to VV. Okay, this is the electric field inside this conductor, and like electric field doesn't depend on any value, that is a constant electric field. Then if you talk about electric field is a constant, that means you can write a potential difference from this to this. So B, this is a this is a P and this is R, so Vp minus Vr is equal to E into D. So E into D is equal to L, length of the rod, L, and E again calculated is V into VL. So VVL is the potential difference between the point P and R. Okay, so that is the answer. The EMF, or you can say a voltage, or you can say a potential. Okay, potential. So you can also generalize this formula. Let me write fast. So this formula can be generalized in vector form, that is like electric field is equal to V cross B. Okay, this is formula. and dot L, and L is also a vector. So if there is a like a rod moving with velocity b, and there is a magnetic field inside, and this is the constant magnetic field, okay, and this rod, so we can write this formula and we can calculate this electric field. And this is not electric field basically, this is whole video whole about the Vp minus Vq, and this is a P and this is a Q. So this is basically, this is a positive and this is negative. So that's all in the video. That's all. Thank you.